We are given here a formula for C in terms of V, with C being the fuel consumption in miles per gallon and V being the speed in miles per hour. So this is a formula that models that, and it's valid between 0 and 80. So suggest why Jamal's included an upper limit. So obviously the lower limit makes sense because we're talking about the speed, and the lowest speed could be 0, but why is there a maximum speed? So this is part A. Well, there's a few answers that are accepted, so I'm just going to show you the mark scheme. In fact, you could say that potentially there's a maximum speed of the car was 80, or you could point out that actually as V gets bigger, eventually it will become negative. Or finally, you might just say that actually the model doesn't apply above 80 miles an hour. Let's take a look at part B. Determine the speed that gives the maximum fuel consumption. Now this is actually a negative quadratic, so it will look like this. And we are being asked for this point here, essentially at the top. To get this in a rigorous way, we need to, actually there's three approaches, but the one that kind of jumps out to me is to use calculus to find the stationary points. I just want to point out, if you try some values, if you try like 40 and 60, and actually the answer is going to be 50, and then even either side, it's not really rigorous enough. How do you know for sure? You need to use calculus. There are another two ways you could have done it, and I will talk a little bit about them. So, right, let's go with calculus. Let's find dc by dv. When we differentiate that 12 over 5v, we're just going to get 12 over 5. And then if I differentiate this, I bring the 2 down, so it's going to be 6 over 125v. And this equals 0 for max or min, or actually stationary point, because you could in theory get a point of inflection. You won't for a quadratic, but this is the condition. Now I can solve this with a calculator. Actually, what I'm going to do is times through by 125 just to make it a bit nicer. So when I times through by 125, it will disappear from here. Now I'll end up just timesing the top by 25. 12 times 25, which is 300. So you get 300 minus 6v equals 0. Of course, you might have done it by adding this and then dividing by that fraction. That's fine as well. So 6v equals 300. V is going to equal 50. Now, I will also write the unit in, and I think you get marked on it in this case. It is good practice anyway. So V is equal to 50 miles per hour. Actually, we're not quite done. It does say determine the speed that gives the maximum fuel consumption. It doesn't. It's not like explicitly saying so, but it is. You are expected actually in this question to show that it is a maximum. I suppose the hint is that it's a 4-mark question. So for this, there's a couple ways you can do it. Actually, I think it's absolutely fine to point out that it is a negative quadratic. It must be a maximum. It doesn't mention that on the mark scheme, but it seems like it would be okay. If you want to just be extra sure, look at the second derivative. d2c by dv squared is equal to minus 6 over 125. That is less than 0, so this is a maximum. Okay, and that's a rigorous way of showing that it's 50 miles an hour, and that's the maximum. Just for info, another way you could have done this question is you could have completed the square. On the quadratic, that seems, this one, that seems way unnecessary, to be honest. There's fractions and everything involved, much better to use calculus, but you could have done that. It was accepted if you kind of plotted the graph as well fairly accurately. That was okay, but I'd go with this approach. When you're finding maximum and minimums, try and use calculus. For next bit, we've got the Amaya's car that does more miles per gallon than Jamal's car. She proposes a slightly different model. Here we go. It's the same, except we're adding a positive constant k. Why is this not suitable? Well, the answer is that when v is equal to 0, you've still got some consumption in your car. That doesn't make any sense. The car's not going anywhere. So that's the reason it's not valid. When V equals 0. C is going to be greater than 0. Whereas it should be 0. Words to that effect. The very last part suggests a different change to the formula, which would give a more suitable model. And there's a couple of answers in the mark scheme. So first of all, first option is to basically take the original model and multiply it by a constant, but it's got to be greater than 1. Like maybe it's 1.5 or something. That means you're getting more miles per gallon. Yeah, anything that's more than 1. Another thing that's accepted would be to actually have the original model and then add on k times that, where k is greater than 0. So both accepted because in both of these cases, when v is 0, the consumption will be 0.